Hi, Zach McKinney here with Team 16, along with Brandon Ward, Keith Snyder, and Eric Bentley. This is our final video progress report and possibly the last assignment we'll have to submit at Arizona State University, at least as undergrad students. So we're very excited today. As a reminder, Team 16 named our project the Smart Current Analysis and Data Acquisition Project. That is a bit of a tongue-in-cheek reference to the SCADA industry, but it does describe the two facets of our project: smart current analysis and data acquisition. As a reminder, we've installed two split core current transformers on the main service entry conductors of a residence between the meter and the main breaker. Now, using these two current signals, we process the data through an input circuit to a microcontroller, where we perform a fast Fourier transform, converting the time domain signal into the frequency domain. We take the results of the fast Fourier transform, along with some other calculations that are done locally, and send that data up into the cloud using an Internet of Things architecture. We've selected the Google Cloud as our host, and we're using a Google Sheet as our database, where we perform further analytics, calculate other KPIs such as update time, connectivity time, and things of that nature. And we've developed some really interesting dashboards that allow users to identify what equipment is using the most power, just identify what equipment is on or off, and what equipment can't be identified. We found that a lot of people will, in your quest to identify all the different pieces of equipment running in your home, there's this base load that you can't quite identify. Think about all the LEDs, chargers, all the electronics that are plugged in 24/7, 365. They're just there eating power away. And so while, of course, we want people to turn the thermostat down in the winter and up in the summer to reduce your heat and air bill and power consumption. And of course, we're going to turn the thermostat down on our water heater. There are those big loads. Identifying all the little loads, or not being able to identify all the little loads, motivates us at least to turn those loads off. So we're able to reduce our power consumption and our environmental footprint in a way that doesn't impact our quality of life, those creature comforts that we're used to. Brandon's going to talk to you about the hardware solution, the input circuit, and the local calculations. Keith's going to talk to you about our data acquisition, the cloud analytics, and the dashboard, some of the software that have been developed. And Eric's going to talk to you about our budget and give some closing remarks and the general conclusion and cap it all off for us. So with that said, turning it over to Brandon Ward. Thank you.
Thanks, Zach. As promised, I'm going to go over the hardware. So this is what we ended up on. Two CTs, the Photon, and I got this mounted on a soldered PCB. And then we have over here the final result, the Photon on the breadboard. So we essentially have the CTs connected in the top of the breaker panel, comes down, measures all the current that's fed into these branch circuits, and then it comes over here into the Photon. We got the puts a positive bias voltage divider so that the Photon can read it, and sends it over to Keith's stuff, the Google Sheets, and Keith's got it crawling through our spreadsheets every night, and he's going to show you how to do that. So Keith, I'll turn it over to you.
All right, thanks, Brandon. My name is Keith Snyder. I'm going to talk to you guys about the software side of our project. Like Zach said, we decided to use Google Sheets for the back end of this device. The reason is it's easy to use, it's cheap, and it's got a relatively robust scripting language that allows us to do all the analytics we need to do. So as you can see here is the data coming from the Photon. You've got two phases in your house, the blue and the red for phase A, phase B. There's a column for the RMS current, and then columns for whatever user-specified frequencies you want to look at. So you can see we have samples coming in about every 8 seconds. And for example, right here where I've highlighted, you can see the RMS current drops on both phases. So that's the downstairs air conditioner shutting off. So you look at how these columns change when appliances turn on and off, and put that here. These are the signatures for each device, and that allows you to use a script to go through all the data at the end of the day and see how long each device was on and how much power you used. So once you have that, you can make some graphs. For example, here is just sort of a visualization of our RMS current on each phase. You can see where both lines go up. That's the air conditioner cutting on and off. Just one of them is going up. That's a 120 volt appliance turning on or off. So then you can make graphs of your daily power usage, and you can also break it down by appliance. If you want to see, for example, here, this purple is our downstairs AC using up a pretty good chunk of our daily power usage. And then you can take these graphs and you can import them into a website so you can view them on any device you'd like. That's the software side of our project. So now I'll turn it over to Eric to close us out. Thanks.
Thanks, Keith. As Zach previously mentioned, this is a DIY project, and anyone looking to do something DIY wants it as cheap as possible. And if you're looking to save money on your electric bill, obviously you want to keep the cost down as much as possible. So other similar products on the market that do what our device does or cost $300 or more. Our original budget was set at $100. And that's where we were at the end of last semester. We were right at just under the $100 mark. And now through simplifying the design and simplifying the way we process the data coming in using Google Sheets, we were able to remove some hardware, and now our budget stands at just under $60, which is pretty tremendous. So throughout the project, we were on time and we met all the deadlines on our Gantt chart. I can't recall one time where we were even a little bit late on a deadline. So as far as project management goes, we kind of fulfilled the golden rule of project management. We were on time and we were under budget, which is pretty awesome. So with that, I think I can speak for everyone in Team 16 when I say that the Senior Design Lab has been a very rewarding experience. I believe we all learned something new and had a chance to apply the knowledge we picked up in our EEE courses. We're all very excited to graduate and put our electrical engineering skills to good use. So thank you for your attention. Team 16 out.